Let's take a look at these bell ringers from today in your crosswalk workbook. Again, you have multiple choice questions, so just like yesterday, if you wanted to, you could take your answer choices one at a time. Say, I'm going to try A first, which is x is equal to -8, and then come over here and plug in values for x until you get a true statement. Hey, but I want to get more practice with actually solving equations. Yesterday I wanted to show you that so you know it's a possibility to do that with multiple choice. But for our purposes, we're not going to have multiple choice for our test, and we need to get more practice with solving these equations. So the first thing I want to do here is to isolate my variable. I don't have any distribution that needs to be done. So to isolate the variable term here, 3/4 x, I need to get rid of the 9 by subtracting it on both sides. So your 3/4x is going to come down, and 3 minus 9 is -6. And the way that we get rid of a fractional coefficient is that we multiply by the reciprocal. And we haven't seen one like this in a while, and so this is a good review for you. When you have a fractional value attached to the variable, multiply by the reciprocal to get rid of it. If I do that on the left side, I have to also do that on the right side. Reciprocals multiply to give us a value of +1, which is why I wanted to do that. And then over here, we can put any whole number over 1 if we want, and you end up with -24 in the numerator and 3 in the denominator, which reduces to -8. And so your correct answer choice for number 4 was A. Number 5, I do have distribution that needs to be done on the right side of the equation, so that's my first order of business. Take the 2, distribute it here and here. I can go ahead and bring down exactly what I have on the left because nothing's happening over there. 2 times 2t is 4t. 2 times -1 is -2. And then I've got this variable constant on the left, variable constant on the right situation that I've seen fairly often. So pick one or the other here, the 6t or the 4t, to get rid of. I will get rid of the 4t by subtracting it. That goes away. 6 minus 4 gives me 2t. The -8 comes down, and the -2 comes down. Now I'm down to a two-step equation. Add 8 to isolate the variable term. That's going to cancel. 2t comes down. -2 plus 8 is +6. Last step here is to divide both sides by 2. T is equal to 3. And I missed something somewhere because that is not one of your answer choices. So let's go back and see what I missed. 16. Oh, that's what it is. Copied the problem down wrong. So that should have been a +1, making that a +2. Okay, so this would have been 2 plus 8, or 10, and then when we divide that, we get t is equal to 5. So answer choice D. Okay, sorry about that. Number 6, we have distribution that needs to be done here. So distribute the 3 inside your parentheses. Your 12k minus 1 can just go ahead and come down. Not doing anything to that side until I get done with my distribution. 3 times 4k is 12k, and 3 times -1/3 is 3/3, or 1. Okay, now at this point, if you realize, hey, I've got the same thing on both sides, and no matter what I plug in for k, if I multiply it by 12 and then subtract 1 from it, I'm going to get the same thing on both sides. Okay? If you don't notice that, then just continue on the way you have up to this point. Pick one of the variables to get rid of, and what's going to happen there is it's going to cancel that on both sides. The -1 comes down, the -1 comes down. This is a true statement, which means it does not matter what I plug in, I'm always going to get a true statement. So all real numbers for your solution here. If this ended up being a false statement, something like 2 is equal to 3, when you have a false statement, that means it does not matter what I plug in for the variable, I'm going to end up with a false statement. Okay, so true is all real numbers, false is no solution. These are the phrases that I want to see in these scenarios. Okay, so not NA and not anything or whatever you might come up with for all real numbers, but these two phrases exactly in these scenarios. Go ahead and let's get your homework from last night out on your desk. The More Equations worksheet, we're supposed to finish the back of it, so if we need to pause the video and give everybody a chance to get this out, pencil, calculator, all that good stuff, and get ready to review that. Okay, so yesterday we worked a few of these together where you have the variable located in the top of a fraction. And so I want to get rid of the division before I get rid of the addition. And I've got to get the variable out of the fraction before I can begin to solve. So first order of business here is to multiply both sides by 2 to get rid of that division. Then what I'm going to be left with is what I had in the numerator. Okay, so z plus 21 comes down. 2 times 18 is 38. Now I have a fairly simple one-step equation. Okay, so isolate the variable by subtracting 21 from both sides, and z is equal to 17. And as always, you can go back and check these by taking your answer and plugging it back into the original problem and making sure that you get a true statement. Okay, for number 12, it's very similar, but the first thing I do here is not get rid of the division because I have another operation on that side of the equation with it. And so I want to isolate what's in the red brackets first by getting rid of the -3. Then once I isolate the fraction itself, then I can begin to isolate the variable. Okay, but I can't isolate the variable until I isolate the term in which the variable exists. So in order to do that, I'm going to first add 3 to both sides. My fraction x plus 30 over 6 is going to come down. 5 plus 3 is 8. At this point, I have the exact same type of problem that I just worked in number 11. And so following the same steps as I did from this point on as I did in number 11. I want to get rid of that division by multiplying both sides by 6. That's going to leave me with x plus 30 on the left. 6 times 8 is 48. And again, I have a one-step equation here to finish this off. Subtract 30 from both sides, and x is equal to 18 for number 12. All right, number 13 is worked exactly the same way as number 12. I first have to isolate this whole fraction before I can isolate the variable. To isolate the fraction, I need to get rid of the 9. I do that by subtracting. And so the 9's cancel on the left and leave me with b plus 4 over 8, and then 12 minus 9 is 3. Now that I've isolated the fraction, I want to isolate the variable. The next step here is to multiply both sides by 8. So that's going to cancel the division. You're left with b plus 4 on the left side, and then 3 times 8 is 24 on the right side. Again, a one-step equation to finish this out. V is equal to 20. Alright, let's scroll back up here and look at number 16. It's worked exactly the same way as the last two. And the only difference here is that I'm adding a decimal, okay, which is no big deal. So add 2.5 to both sides here to isolate your fraction. So now we've got 60 minus t over 4 is equal to 12.5. Now that I've isolated the fractional part, I want to get rid of the division. In this case, I need to multiply by 4. That's going to cancel the 4 on the left side, and then 12.5 times 4 is 50 on the right side. And so it ends up in a little bit different format here, but it's still a one step to isolate the variable. And so you subtract 60 on both sides, and that leaves you with a minus t is equal to a minus 10. But the coefficient on this variable is negative 1. I don't want a coefficient of negative 1. I want a coefficient of positive 1. And so you can either look at it one of two ways. If negative t is negative 10, then positive t is positive 10. To some people that might make perfect sense. Or just look at it this way. I've got a coefficient on the variable. I need to get rid of that coefficient by dividing. Same way I've always done. If I divide on the left, I need to divide on the right. Those two cancel and leave me with t. Negative divided by a negative is a positive. Alright, I did not notice when I assigned this, but 17 and 18 are like number 4 that I told you yesterday we're not going to worry about. Okay, so if you struggle with those, then don't worry about it. We're not going to work on this type of equation for right now. You'll not see this on your test. Okay, so the type of problem we just worked here, this is as far as we're going. Everything we do from this point out is going to be to review for the test.